TV segments on Weather Geek with the Weather Channel, as well as his articles that he writes and his editorials that he writes to the Forbes magazine, which really open up the weather and climate area to a much wider audience. He has also been awarded for his communication and outreach efforts through the American Meteorological Society. He has received a distinguished award from the American Association of Geographers. And before coming to University of Georgia, he was with NASA, Goddard, where he was also honored with the Presidential Award for his work on rainfall and satellite data sets. And sort of like he's known for reviving this whole notion that was started with Shagnon and Landsberg about the rainfall modification through urban environments. And you can see that his 2005 paper really laid the benchmark for everything that is followed in terms of the community thereafter. So it's a real pleasure to invite Professor Marshall Shepard, and he's going to be talking about what's next after that. And he's scheduled till about 9:15, he would like to say, because he has to rush to Penn Station as soon as he can after that for his other commitment that he has. But let's welcome Marshall Shepard. Thank you.
I think she's coming.
That might be helpful.
Let me just... Thank you. It's really an honor to be here, and I appreciate those gracious remarks by my friend and colleague, Dev. It's actually my first time at this particular conference, not the AMS part, but the international conference, so it's really an honor to be here. When asked to talk, I thought about what I wanted to share with you today, given the fact that I guess most people in this particular community know my work as it relates to urbanization and precipitation. And so I thought about that, and I said, well, I don't want to go up there and give a retrospective of urban precipitation work. I will hit it briefly, but I want to talk about what's next as it relates to urban research and precipitation from the perspective and vantage point that I have. So the title of my talk is Beyond the Question, Does Urbanization Affect Precipitation? What's next? And that's just a really neat picture of Atlanta, Georgia, with the city of downtown Atlanta poking through the cloud deck there, probably some type of urban response there, as you see. So I always like to start the talk with that picture, even though it's not necessarily rainfall related. So I want to when I kind of got into this, and I want to acknowledge Professor Bornstein, who I know is in the room, because some of the earliest interest from me was after seeing some of Bob's early work that was coming out of the Project Atlanta that I know Jeff Lavelle and others were involved in as well. I remember reading a paper by Bornstein and Lynn, or saw a presentation somewhere, and I just, being from Atlanta and the big Project Atlanta experiment going on, I just became very intrigued with the notion that a city might be causing or affecting rainstorms. And so at the time that I think, this was probably late 90s, early 2000s, and at that time, I think the question still was, can cities or urban areas initiate, modify, or amplify precipitating questions? I think that was still the guiding question. I think there was still a question about whether it could happen. But have we answered that question? I think the answer to that is yes. I think we know conclusively that cities are initiating, modifying, or changing precipitation under certain circumstances. I think if anyone asks you that in the urban climate community or outside of our community, the answer to that question is yes. So here's an example. I sit here and watch this all of the time in Atlanta. This is on my Radar Scope app, and this was a classic weekly force day in Atlanta, no frontal systems, no boundaries, and this little thunderstorm popped up right over Atlanta. And eventually others popped up in that same location and drifted downwind. So this is not an anomaly. This is not a cherry-picked case. I watch this all the time. In fact, a colleague of mine at the Weather Channel, Stu Ostro, he calls them sunset sprouters because he noticed that around sunset every day and around Atlanta, these things tend to pop up and drift downwind. So the next question that comes to mind is, do we understand the processes that cause the urban precipitation effect or the urban rain effect, if you want to use URE or UPE? And I think the answer to that is somewhat. I think we generally know everything that's in the mix, but I think there are different perturbations of what happens under different circumstances. And Sue Gramont and Bob Bornstein and perhaps Dev and others will recognize this. I don't even remember which of you initiated this figure, whether I can't remember if it was Sue or Bob, whomever it was, but this was a really nice attempt, and maybe, I don't know exactly who the credit, but I tried to capture who I thought I got it from. It really was a nice attempt at trying to capture the physical processes that cause urban rainfall effect. I modified it with a few things as well. So my point of showing this slide is I think we know the physical processes, but pulling them all together still somewhat of a challenge. All right, but here's the question, and I was just talking to some colleagues about this morning, Gerald Mills, in fact. Are practitioners, stakeholders, and forecasters utilizing this knowledge? I just sat here and established that we know that urban environments are affecting precipitation. Are practitioners, planners, stakeholders, are they using this information? I think the answer to that is a resounding no. I think this is still languishing in the world of academia, but yet there is a real value in this type of information. Let me give you an example. Here's some work from University of Georgia. We published this several years ago, showing the rainfall climatology in the warm season. And you can clearly see some things that would make sense if you're a meteorologist or a climatologist. You see the rainfall in North Georgia associated with the mountains. You see the rainfall in the coastal plain associated with coastal plain and sea breeze intrusions. But look to the east of Atlanta in that box. You see the urban rainfall anomaly that many of us have established for years. Now, stay with me, because if we know there's an urban rainfall anomaly to the east of Atlanta, which we have clearly shown in paper after paper, then look at this. Here are the proposed water supply reservoirs in Atlanta and Georgia. We use surface water for the most part in Georgia. And the red is reservoirs in the pipeline, in the planning pipeline, and then the white circle as those that have been built in the past 15 years. Now, if we know that there are certain places that are anomalous in terms of rainfall, that can guide where we might put future reservoirs. So it's just an example of how this is really a scientifically interesting problem, urban rain effect, but there are ways that we should and could be using that information, even in terms of precision agriculture, for example. So that's really a message, if something to take from my talk today, among others, is that and this is not just related to the urban rainfall, we have got to get this information into the planning, stakeholder, and other phases. And I saw many papers and talks here. I know one of my students, Mariana, is here somewhere, and she's really thinking a lot about this for her dissertation work as well. So I'm going to sort of breeze through this because in the interest of time and the fact that I have to take a train here soon, the history of this goes back to the 20s. I mean, people like me and Bob and others have done this work, but you have to go back to Horton and Landsberg, of course, the work of Chagnon and Huff and the Metromex experiment. That is really where I would say the early glory days of this urban precipitation work came about. And as I mentioned earlier, I got interested after the Project Atlanta and the Bornstein papers that I had seen. But something interesting, in 1998, this was also a very important paper for me. It was a paper by Lowry, and I believe he published this in Physical Geography. And Lowry actually questioned some of the methodology, some of the earliest work on urban precipitation. He questioned the notion of focusing on one city at a time. He really argued that we need designed experiments with legitimate controls, replication in many different urban areas, and disaggregation. All of these things were coming about, this paper was coming about just as NASA was starting to launch a satellite that can measure precipitation from space, called the TRIM satellite. And that's where I cut my teeth as an early scientist coming out of Florida State and then becoming a scientist at NASA. And I was like, hey, this satellite can measure rainfall anywhere in a tropical, really from 38 to 38 south, but we have some ways to even extend that to 50 north and 50 south by blending it with infrared data. So I was like, I can look at this, I can look at multiple cities using this satellite data set. And so that was really the impetus for sort of publishing our paper in 2002, sort of looking at multiple cities at one time, rather than just sort of focusing on one city in a field campaign or field experiment approach. And that's really where we started moving forward. And so I like to show this figure here because I think, there was sort of this second period that started around 2002 or so. I think even Sugerman and Sauch in a paper in 2006, we appreciate the nod, but noted that our work in this area really sort of stimulated sort of the next wave of research in this area. And so people will often say, well, is it just something isolated? And I show this map, and it's not updated, so if you don't see some of your work on there. But my point of showing this is that studies on the urban rainfall effect have been conducted everywhere around the world. This is not something isolated to St. Louis or Atlanta. We've seen studies in Japan, China, South America, Europe. So this urban rainfall effect is real and it's widespread. So not only is it real and widespread, in this sort of era after 2002, where we sort of introduced satellite data, we started showing that even in the satellite-based data sets, we're seeing the urban rain effect. Here's a really interesting look at the difference between the rain rates, 1 degree average rain rates from the precipitation radar in urban versus rural spaces. I think Dev Niyogi and his group did some of this work. Walker Ashley and colleagues at Northern Illinois have done work where they showed using radar, Doppler radar, that clearly within and just slightly downwind of cities, you have elevated radar reflectivities, and that's what this figure is trying to convey. Again, we don't have to get into the technical details. I'm just walking you through that from a satellite perspective, there's evidence in the literature. From a radar perspective, there's evidence in the literature. Using models, this is some work we did where we simulated urban sea breeze interactions around Houston, and you can see the arrows represent the low-level surface flow, the purple represents cloud water, and the yellow represents rainwater. And you can see in the no urban versus the urban case, you see a very different development of thunderstorms around Houston, something we've published about. So our models are good enough to establish the urban rainfall effect. And this is a paper that Jordan McLeod and I and Chip Conrad just published in Urban Climate, establishing using a new rain gauge radar blended product called the multi-precipitation estimate. And there's the urban and downwind anomaly and rainfall around Atlanta. So irrespective of what your methodological approach is, we have plenty of evidence of the urban rainfall effect. So that's why I say that question has been answered. Now take a look at this radar image here. And what you're going to see is storms generating just south and west of the metropolitan Atlanta area. They're drifting to the southwest and they're producing outflow boundaries. The reason I show you this is because one of the most important sort of new results that came from this 2018 paper that I just mentioned is that in the urban rainfall community, we get used to this notion of the downwind. We say that there is an urban effect and there's a downwind effect. But one of the most important things that I think we showed in this paper is that downwind is relative to prevailing flow. So you have a climatological downwind area, but on any given day, the urban effect may manifest itself in downwind as a function of the prevailing wind flow. So on this particular day, even though the downwind region is the eastern part of Atlanta there, on this particular day, we had northeasterly flow. That means the winds were out of the northeast. So downwind on that day was in the southwest. And so you can see that we had those storms generating on the urban-rural fringe or boundary of Atlanta. And so that's, I don't want to go through the details. We proposed in this 2018 paper something called the flow regime-dependent downwind anomaly. So we have sort of a climatological downwind anomaly, but then we have the flow regime-dependent downwind anomaly depending on the meteorological conditions of the day. So that's a new wrinkle in the discussion of the urban anomalies. So what, again, if you want to sort of know the physical mechanisms associated with the urban rainfall effect, Chandana Mitra, who's here in the audience, and I published a book chapter in 2016 that talks all about it. Atmospheric destabilization from thermal mixing due to low-level heating, increased turbulence and mechanical mixing because of roughness, modified microphysical and dynamic processes, and bifurcation, which I know Bob Bornstein has some interesting work forthcoming. So these are the things in the mix. These are the things that we think are causing the urban rainfall effect. All right, so with all of that context, what's next? And I want to use this last part of the talk to sort of say where I think we need to be going on urban precipitation research. We've got to move beyond the studies just that show, oh, here's another example of the urban rainfall effect, because I think there's enough science evidence to say that. So where do we need to go next? I'm going to walk through each of these. Extreme precipitation and urban flooding. Is there an urban winter precipitation effect? Urban effects on severe weather and tropical cyclones. Urbanization and broader hydroclimate change. And the role of urban climate archipelagos, and how we make it all actionable. These are the areas that I think in this particular discipline of urban climate that we need to be moving. So extreme precipitation and urban flooding. And I'm going to be U.S.-centric here for a moment. We know that flood risks are increasing. The top 1% to 2% rain events in terms of intensity are increasing. The IPCC, the National Climate Assessment here in the United States, and others have shown that. So I think there needs to be a bit more research focused on urbanization as it relates to extreme precipitation. This is, again, some work of Kishtwal et al. From Dev's group. Dev and I have published several papers together with his group over the years. And this shows the open circles showing heavy precipitation events have a positive correlation in India with increasing urbanization and population. This was a paper in 2010 that kind of scratched the surface, because here's the reality about most urban precipitation studies if you go back into the literature before about 2008. Most of them tend to look at these weakly forced summertime convective systems, not necessarily the heavy rain events or extreme precipitation events. So we really need to think more about the urbanization signal in extreme precipitation events. Here's some work from Niyogi et al. 2017. I think I'm an author on that paper, I'm not sure. And it shows the probability distribution function of rainfall changes over urban and rural areas from 1990 to 2008. And actually in that paper, it's broken out by region as well in the US. So clearly, even in terms of rainfall and extreme rainfall, there's a signal. That leads to the question, is the urban effect detectable in surface hydrological processes? And I think we know the answer to that. We know the urban water cycle is different from a natural water cycle, because in the urban environment, there's increased runoff, there's less infiltration because of impervious surfaces. So we know that the water cycle in an urban space is different. And so does that convey in terms of land surface hydrology? Well, it does. Here's a paper that my former PhD student, now Professor Neil Debbage at University of Texas, San Antonio, published, where we're looking at this mega region that Gerald Mills talks about mega city region between Atlanta and Charlotte, North Carolina. We call that Charlanta. And what we found is that more urbanized watersheds exhibit greater numbers of high and low threshold exceedances, as well as larger peak unit discharges. Now that's hydrological terminology that says that because of urban surfaces, you get more runoff in these watersheds and you get more flooding. So this is a paper, if you're interested in this paper, it was just published in Water Resources Research, a journal of the American Geophysical Union. Let me put a bow on that thought. So where I really wanted to make the recommendation there is that we need more studies that are coupling our knowledge of the urban rainfall effect with hydrological runoff and hydrological modeling, because that has direct impact on society as far as applications. What about the urban winter precipitation effect? Is that real? Well, if you look at this example here from a 2011 satellite image, you can see the Twin Cities urban heat island sticking out because it has a warmer land surface temperature signature. Now, this is interesting because Stan Chagnon actually published a paper several years back that said cities may have less freezing rain events because freezing rain happens when you have a shallow, warm layer where when the rain falls, it's too warm at the surface to freeze, so you don't get, when you have freezing rain, it's below freezing, and so you get freezing rain. The rain falls as liquid, and then it freezes at the surface. But in an urban environment, if you have an urban heat island, you may be able to stay just above that 32 degree or 0 degrees Celsius freezing mark, and so you have less occurrence of freezing rain. Well, my current PhD student, Brad Johnson, and I just published some work in Urban Climate showing that this may be the case. We looked at the corridor from Washington, D.C. up through New York, and we were interested in precipitation type that tends to occur in these large nor'easter or big snowstorm systems that move into the northeastern United States. And what Brad found, this is a part of his dissertation work, he found that as distance to the urban centers increases, observation of mixed precipitation increases. And he also found that during these mixed events, if the winds are less than 6 meters per second, the urban heat island remains intact. If the urban heat island remains intact, that's going to reduce your freezing rain occurrences and might introduce more of a mixed phase type precipitation. So this is an area that, again, we're scratching the surface on in terms of research, but I think there's fertile ground to really explore urban impacts on wintertime precipitation. What about urban effects on severe storms and tropical cyclones? That's really it. I'm going to just put an emphasis mark. This is a frontier. For any graduate students interested in this topic, this is a real frontier area for research. There's not much done on this research right now. So here's a look at a squall line that was passing through Minneapolis, Minnesota several years ago. Kenny Blumenfeld sent this to me because he knew the type of work that I was involved in. And he said, take a look at this. Let me see if I can get it to go one more time here. And what was happening there is you had a squall line moving through, and if you notice over the city, boom, it really explodes. And Dev and others, Dev and Yogi 2011 and others have really started to look at this idea of, can we now move beyond just looking at little weakly force thunderstorms or initiation? Can we now enter the realm of trying to understand if cities are affecting large-scale events or strong synoptic forcing? In other words, a thunderstorm or a mesoscale system that has plenty of atmospheric forcing, but can we still see the urban signature in it? So tornadic storms are impactful. You can see here the tornado tracks from 1950s up to the early 2010s or so. You can see that if you don't like tornadoes here in the US, move out west. They don't get very many. But more importantly, do urban environments affect tornadic storms? Now, Deb and I thought about this years ago. We had a tornado that came through Atlanta in 2008, right through downtown Atlanta. And Deb and I started saying, well, was there an urban effect? No one had really done any work on this, and unfortunately, we never published this in a peer-reviewed literature. But Dev and I actually thought carefully about whether there was an urban effect on that Atlanta storm. In fact, we did some model simulations where Dev had this idea, hey, let's just put in more realistic urban land cover from Modus in Wharf. And when we did that, we did see a different response to the supercell thunderstorms that caused that tornado. So, I think Dev and I were sort of pioneers in this work, even though we never published it, but now there actually are people doing this type of work. This is a paper that just came out in Monthly Weather Review by Larissa Reams and David Stensrud. It's called Influence of a Great Plains Urban Environment on a Simulated Supercell. Supercells are the types of thunderstorms that have rotating updrafts that produce tornadoes. And what she found in this work is that they suggest that urban areas have a significant impact on storm characteristics, particularly low-level rotation in the mesocyclone tract. They also found that storms where the storms pass to the north of or directly over the city late in the life cycle deviate most significantly, and in their ensemble members, low and mid-level cyclone strength increases in the mesocyclone tracts further south when compared to the control. Here is evidence that the cities of a Great Plains area are affecting the intensity and track of tornadic storms. That is a forefront research problem. So I was really excited. I actually was a reviewer on this paper, so I was aware of it before it came out. But I was really excited to see this work because it really was, to my knowledge, the first published work that kind of took this idea that Dev and I had 10 years ago and brought it to fruition. What about tropical cyclones and hurricanes? Well, here's the 2018 typhoon season so far for our colleagues in the room from East Asia. You're certainly familiar with the typhoons this year. We're having a fairly quiet hurricane season in the Atlantic, but the typhoon season is certainly picking up in the East and Western Pacific. Many of these typhoon tracks have tracked near cities. So, as I think about the U.S., here are the coastal cities and the return intervals or periods along the U.S. coast. As I think about this is something that I thought about many years ago, but just never have had the time to do the research. Do cities impact landfalling hurricane rainfall? It's plausible. That's a plausible research question. And what really got me interested in that research question, I was at a conference somewhere, and I saw Lai-Ying Zhu at Texas A&M put this figure up. And it's a figure showing tropical cyclone rainfall in Texas from 1950 to 2010. And what popped out to me is that there seem to be these little sort of anomalies in a couple of the urban areas. Now, some of that might be sampling and in the observations, but I've seen some research using radar data that suggests that that might also be an urban enhancement of the rain bands over the cities. Again, this is frontier research. No one has done this research and has published this research. I know there are a couple of people thinking about it right now. So here's, again, I'm a satellite guy at heart. So I was the deputy project scientist for the Global Precipitation Measurement. This is the rainfall from the GPM satellite for Hurricane Harvey. As Harvey approaches land as a hurricane, Cat 4, and then parks itself over the Houston area as a weak tropical storm for 4 to 5 days. It ultimately produced over 50 inches of rainfall. Now, the research questions in this are, as a weakening or decaying tropical cyclone interacts with an urban environment, are the rain bands or the convection in any way enhanced? Because we think that happens in other convective systems around the planet. So are those anomalies real, or are they an artifact of the data? I think someone needs to look into that. Maybe it'll be us, I don't know, but someone needs to look into that. Connectivity to the changing hydroclimate. We know that urban effects on climate scale both ways. There are impacts that go from the local scale up to the global scale, and then of course the broader climate change that we're seeing at the global scale scales down to the local scale. And I've seen talks and posters here at this conference that are sort of thinking about that from a perspective of heat and other things. One of the areas that I think is poorly represented in the broader scientific literature and discourse is an understanding of urban water cycle processes at the global climate modeling scale. How do we integrate this urban land cover, urban aerosol effect on the water cycle into our climate models effectively, so that we can then be able to say some things about downscaled effects, not just on heat, but on precipitation and hydrological processes. That's a fertile ground for research that's needed. So for example, 2010, we published a paper in Environment and Planning B, where we had planners in Houston project out the growth of the city of Houston to the year 2025. And we then just took that land cover from 2025, we put it into a mesoscale weather model using the same atmospheric conditions from 2008, which is what we were doing that study. And we got a completely different rain field just as a function of the fact that we used the 2025 land cover of Houston that was projected by the Houston-Galveston Area Council. Now that was just a response from the land cover. What happens when we put the land cover in a climate model that is capturing all these sort of processes in a wetter, moisture climate environment, and then we add in the urban land cover from 2030 or 2050 in cities? These studies haven't been done, and they need to be. And then finally, a few years ago, we introduced this concept of urban climate archipelagos. And it was borrowing from this language of urban heat island, because we know a chain of islands is an archipelago. And there had been some discussion about heat island archipelagos in the literature, but this urban climate archipelago was a somewhat different construct. We published this in an IEEE online journal called Earthzine, if you're interested in sort of seeing more about that. It was borrowing from geographer Gutman's book, Megalopolis, and it also was thinking about megalopolis and megacities, and the things that Gerald Mills and others talk about. And if you look in this satellite image of night lights, even in the US alone, you can see many different megalopoli, chains of cities, urban climate archipelagos, Charlotte to Atlanta, for example, DC to Baltimore, the urban chain along the Florida coast, the Gulf Coast from Houston to New Orleans. Those are all examples. And we talked about that an urban climate archipelago, I defined it in the paper as a chain of distinct urban entities with discernible aggregate impacts on at least one segment of the climate system. So if you need a visual of this, think about the impact that one mountain would have on weather or climate versus what a chain of mountains would have. It would be a completely different response to the atmospheric system, a system of mountains versus one isolated mountain. And so this notion, and Saylor et al., we published some work with Dave Saylor where we included some of this work where we looked at the impact of the Baltimore to New York to Boston urban climate archipelago on precipitation and heat islands in a couple of years ago. So that's a paper by Saylor et al. Now, if I'm a graduate student interested in this, I would take a picture of this slide because in that paper, we didn't do any research. We just put forth the concept of an urban climate archipelago. And I ended that paper with these questions. I said, these are the questions that need to be addressed. We didn't do the research. This was just sort of me being me, thinking about ideas, because anyone knows I have a lot of ideas that I like to get down on paper. So these are a set of questions, if you buy into the concept of urban climate archipelagos, that need to be addressed. And so I want to end with a nod to this report, if you're not familiar with it, called Urban Meteorology. I served as one of the authors on this report from the National Academy of Science a few years ago. And in that report, we talked about and did a summary review of urban climate and urban meteorology, but then we talked about ways that we can make our work that's being discussed at a conference like this more actionable, more usable. That's what I'm interested in these days. I am not interested in just doing research and publishing it in a journal and going about my business. I want a farmer or a planner or a National Weather Service forecaster to think about some of these very things in their day-to-day activities as well. Thank you very much. I have time for maybe one or two questions.
Good morning, very interesting.
Thank you.
I wonder if you have done some research in the tropics and if you can tell about differences, because United States is a different climate, so I'd like to know about it.
No, we have not done too much work ourselves in the tropics. We've done work in places like China. We've done a little work in Europe as well. But I think it's long, one of the people here, and I don't know if he's in the room, but actually Jorge Gonzalez, is Jorge? Yeah, there you go. Jorge has done some work on the impacts of urbanization on San Juan, Puerto Rico, and I believe you did find clear urban effects, is that correct? So there certainly has been work in the tropical regime, and I have seen other papers in the literature as well. So we think this, in fact, in some ways, the tropics may be more susceptible because it's an environment that's ready to convect. In other words, if you can thump the air upward, if you can get it to lift in some way, you're going to get convection. And so the urban heat island or the urban environment through the heat signature and the roughness link can serve as the source of lift.
Hi.
Hello.
Thanks so much for wonderful presentation.
Thank you.
2 questions. In the actionable interest, have you taken the research and put it into planner or spatial development practitioner language?
Oh, absolutely. That's kind of what I do.
Okay.
Yeah, and I'll say, go ahead, complete your question.
And the second question is, in looking at not so much weather events, but the resulting extreme flooding.
Sure.
Have you analyzed within the cities you're looking at the amount of soil sealing, the percentage of surface that is sealed or unsealed? Thanks so much.
No, so the first part of your question is with the Peter and Tracy Twine Snyder, Brian Stone, and others, we had a grant for the National Science Foundation. We had an RCN, a research coordination grant over the past 5 or 6 years. And the task of that grant was to find ways to bring this information to planners. And so we had a series of workshops over the 4 or 5 years of the grant where we invited planners and FEMA and others from around the nation, this is a US-centric project, to these workshops and laid this stuff out for them, but also put it in terms that they could understand, put it in terms of their decision support systems. Because again, often as scientists, we talk in our science world and in our science language, in our HDF formats and NetCDF, and people in that world don't speak that language. They don't care about formats, and they want a GIS layer that they can pop into their decision support system. They want it in a way that, okay. And so we have done that. There are some other things that we're trying to do, but I think there's more. We're still, if 10 is ultimate success, we're at about 0.25 right now. So there's still quite a bit more that we can do in that area. And on the second part of your question, we have not done that, but we actually do have a forthcoming paper. If any of you are reviewing it, and hopefully can get it through the review process at Journal of Applied Meteorology, where we've been looking at the 500-year flood event in Atlanta and the urban impacts there and some things that we are saying about urban runoff and whatnot. So thank you so much. I do have to end it there because I've got to dart out to the train. So
just one last one.
I'll take one last question, sure. I don't know who, I saw 2 hands. Maybe I'll take both. I'll take both. I saw your hand and I saw the one that's in there. Yeah, good. I'll take both.
Well, actually, I have also 2 parts of the question. First of all, you mentioned what this research is not going to practical realization and service practice.
Not as much as it could.
This is what I would like to stress. What yesterday and the first day we informed about WMO program for integrated urban services, where this concept is very much involved, and seamless modeling approach what we try to convince for our members and national meteorological services to realize, include these feedbacks between urban areas and the meteorological process. So I think it would be really good with scientific community to continue this work and realize into practical services, what yesterday one of my colleagues informed.
Absolutely.
Second part, always you stress urbanization issues due to urban landscape, but when we consider effects of urban areas on thunderstorm and for precipitation, first of all, it's combination of atmospheric pollution from urban areas and urbanization itself. So this required also a new type of tools and processes analysis with feedback between chemical and aerosol processes with meteorology. And in this direction also, you probably know, European scientists did a lot, and Megapoli project was focusing on such interaction and understanding of mechanism.
Yeah, I put this slide up because this sort of summarizes the 4 things that are involved. And as you see, item C very much talks about aerosols. And so, you know, one of the interesting things, because I've often hypothesized, and I know Dev and Bob and others agree with me on this, I think the landscape is the forcing function for the urban precipitation effect. I think the aerosols serve as the efficiency modulator of the precipitation.
It could be actually in different directions.
It perhaps is, and also, as Danny Rosenfeld and others have shown, aerosols actually have a duality effect. Sometimes they suppress precipitation, sometimes they invigorate. So I think that's an area where there's still some work to be done. So
okay, thanks a lot.
I want to acknowledge your question, and then we'll stop there.
Yeah, thank you for bringing this up, because I think this is really an issue we have to do a lot of basic research in. And we did some of that already for very little cities like Hamburg, where we don't have skyscrapers and stuff like that. And we found that actually, yes, we have downwind increasements, but we found we couldn't attribute it to the city. We could attribute it, and I think that's missing on your list, to the orography, to the natural surrounding. And that's something we should not forget in all these analyses, that we have also orographic lifting. Most cities are in valleys from ancient times. Very few are on top of mountains. So we have to consider that, I think. But I think we should go into all these processes. And what's your opinion if we would be able to attribute the urban impacts on changing in precipitation patterns of a hurricane or whatever? Do you think that's a general result, or it's just a case study and we can't generalize that?
Yeah, I think we can certainly do research. And first, I want to answer your question. Much of the work that has been done in the urban precipitation space has selectively chosen cities that were far removed from major orographic influence, so that the city influences probably could be more isolated. We actually did do some work around Phoenix, Arizona on this problem, where we found that there was and this is a paper published in the Journal of Arid Environment, 2006, and we found that there's this interesting interaction between the fact that you get these thunderstorms that are developing out in the mountains to the east of Phoenix, Arizona. They put outflow boundaries out, these density currents, that then propagate back down the mountain, interact with the city of Phoenix. So there are some of us that definitely have thought about this orographic influence as well. So I did want to make that point, but I'm familiar with some of your work in Europe as well. On the rainfall and hurricanes, I think the way you have to initially approach that, if you have initial sort of observational evidence like we've seen, is the way I would probably start that study is using models. I would want to theoretically understand, using a case study for a particular storm, if there is, and because we can sort of control the environment in like a hurricane WRF, the H-WRF model, for example, and theoretically understand if it's just, it'd probably be a master's project for a student of mine, and I would look at sort of the theoretical impacts of an urban environment on a hurricane. And then once I sort of looked at the results from there, that would then guide me into whether we needed a more robust sort of approach in terms of a methodological, broader study, or perhaps even a field campaign. Thank you.
Thank you very much.
Just wanted to say thank you, Marshall. That was, as always, very well laid out. I'll just make a quick comment about the topography and the urban aspect. There's a paper that came out in GRL in 2018 for Argentina, where in fact there was the urbanization impact in a very complex terrain. And it was surprising that even under complex terrain, when we thought there was not going to be much effect, it does show up very convincingly. So something to look into. But I just want to say thank you again, and a reminder that we are going to have a picture taken. So if we can have everyone sort of come here, and we can then somehow make this happen.